make sure we turn on the record, which now I lost. Oh, here, okay. Okay, I started the recording. And Stefan, you did the same?
I have done the same.
Okay, great. All right, so welcome everybody. Many thanks for joining this Saturday for our talk with Frankie Reamer. I'm a founding NASCA board member and the moderator for today's session. Today's event is part of NASCA's Climate Talks for Everyone series, and it's co-sponsored by Fridays for Future at NASCA and the Climate Elders Action Arizona. We welcome other interested groups to join us in sponsoring this series on educational talks on climate. In organizing the talks today, well, usually we ask folks to stay muted and post your questions via the chat. We're small, so I would imagine that we could have a lovely conversation after Stefan's presentation. So we don't have to be, we could be a little more dynamic than we might be if we had a large group. Also, if we freeze, just hang on for a second and hopefully the Zoom will unfreeze. So I'm excited to introduce my colleague and formerly at NAU and also now at NASCA, who's going to talk to us today about climate refugees and Arizona's future. Stefan is a science communicator, film producer, author, and public speaker, as well as I just said, a founding board member and a speaker for Northern Arizona Climate Change Alliance. He's an affiliate with NAU's Department of Biological Sciences and Center for Adaptable Western Landscapes. He brings expertise in community ecology, sustainability, climate change, and educational outreach. Stefan writes for the Arizona Daily Sun as author and editor of the column Spotlight on Climate. I'm stuttering over that because it always makes me very excited that he organizes that and writes for that column. And he served as executive producer on 4 award-winning PBS documentaries on biodiversity and habitat conservation. So, Stefan, we're all interested in hearing more about climate and refugees migration. So thank you very much. The floor is yours.
Thank you very much, Francis, and welcome everybody. Since we are a small group, I think we could probably, if you do have a question or a comment, unmute yourself during the presentation even, and then we'll have more of a focused discussion at the very end as well. So I'll go ahead and share my screen so we can get into the presentation. Is everybody seeing that okay?
Yes.
Yes.
Okay.
Got it.
So I think I'm full screen now. Is that correct?
Yes.
Very good. All right, so we're going to talk today about climate refugees and Arizona's future. A lot of the climate refugee issues are really global in nature, and they're very complex because, I mean, what does it take for somebody to flee their home, leave their friends and relatives, leave their community, leave their way of life in many cases? It takes a lot. So this is not a light-hearted decision that people make when they flee their homes. And we'll talk about all the different climate-related reasons that people flee their homes. This particular image that I've got in front of you right now is interesting. This is in Bangladesh, and of course they're in an area that is susceptible to flooding. But now, because of climate change, flooding has gotten more intense and more frequent, and people's livelihoods, the way they once lived, are now no longer possible in some areas. And the interesting thing about this line to me is, where does it even begin? Where are these folks coming from? It's just amazing to me that you could be that inundated with water. Here, closer to home, these are folks who are fleeing Guatemala and coming into trying to get into Mexico. And of course, as they flee further north, they reach the US border and have a hard time than getting into the United States, where they become a political football in many ways. We had a president recently who was calling these folks criminals and drug dealers and so forth, when in fact, most of them are folks who are fleeing, farmers and farm workers who are fleeing the land in Nicaragua, Honduras, El Salvador, and Guatemala. We'll talk about that in a little bit more detail as we go along here. So we all know that climate change is causing more and more economic difficulty. Back in 2017, climate disasters of one sort or another cost people in the United States over $306 billion. That's real economic impact. And of course, every year, those economic impacts get higher, and the details as they play out across the globe are different in each location. So we'll talk about that a little bit as we move forward as well. This is from the Scientific American back in November of 2019, where a study was done that projected what's the effect of climate change going to be on the economies of the world, rich countries, hot countries, cold countries, and then specific countries like the US, China, and so forth. Overall, if we do not meet the terms of the Paris Climate Agreement, those are the projections that are in red, then there's going to be very serious global economic problems. If we do meet the terms of the Paris Climate Agreement, then the impacts are less, but still have a negative effect on the economies of most countries around the globe. It's interesting here that China, take a look at this. Why would China be projected to see an increase in their economy if we meet the terms of the Paris Climate Agreement? Any ideas? Well, if you pay attention to what they're doing, they have started to produce photovoltaic panels and wind turbines and are positioned to supply the world as we shift to new ways of generating energy, electricity specifically. They're set to supply the world with what it needs for that major transition. How about countries like Russia? They're projected to see an overall increase in economic productivity. Why would that be? Canada, by the way, sees the same projection. We just don't have all the countries on this particular screen, but it's because they've got agricultural lands at higher latitudes, and as things warm up, the productivity of the higher latitude agricultural fields will increase. And so you should see a net overall increase in their economic productivity, as will Canada. And countries that are at southern latitudes will mostly see declines in agricultural productivity. We'll talk about all of that as we move forward. Before we get into all of that climate refugee stuff, we need to cover some of the basics of the science of climate change. And it's the main thing about climate change right now, it's no longer some theoretical future. It is something that is happening now and is impacting the world in all sorts of ways. So we'll just do brief reviews of the greenhouse effect, CO2 and the Earth's temperature, and the ways in which we know that current climate change is caused by us, by human activities. There's a lot of misinformation out there about climate change, and some of it is subtle. I don't know if y'all remember this ad campaign by the Coca-Cola company, which was projecting that polar bears are happy up in the Arctic because they're drinking Coke. When in fact, they're not at all happy because their habitat is disappearing out from under them. As things warm, the ice flows break up sooner. There are smaller and smaller patches of habitat for them to hunt from. and they have to swim farther and further distances between patches of habitat, and many of them starve to death and are really struggling in this new rearrangement of their natural habitat. We know about the greenhouse effect. Basically, we get a lot of different wavelengths of energy coming in from the sun. They come pretty straight through our atmosphere, and they warm objects when they intercept them on the surface of the earth. So, and we know this, when you go out and sit in the sun, you feel the warmth of that sun. It warms up your surface, and then warmed up objects re-radiate heat energy back out towards outer space. That's a shift in the wavelengths. Many of the wavelengths of incoming radiation are shorter. What's re-radiated out towards space is infrared and longer wavelengths. And greenhouse gases absorb that infrared radiation, those wavelengths, and keep them from reaching back out to outer space. Okay? So the greenhouse gases really act as a blanket to hold in the heat energy that comes from the sun and warms up the surface of the earth. Less of it escapes back to outer space, just in the same way that a blanket keeps you warm at night. If you didn't have the blanket, you would be radiating heat energy towards your surroundings, and you would be losing that heat energy. The blanket keeps that heat closer to you, keeps it from escaping. And that's what the greenhouse gases are doing. And so since the Industrial Revolution, we have been adding to the thickness of that blanket and holding in more and more of that heat. And so it's heating up the Earth's surface, it's heating up the surface of the land and the oceans, and heating up our atmosphere as well. Scientists look at this from many, many different perspectives, and here's another interesting one. We can compare the Earth's greenhouse effect with that of our nearest neighbors, Venus and Mars. We call Earth's atmospheric density at the surface of the planet to be 1 atmospheric pressure, since that's our 1 atmosphere. Venus has a much denser atmosphere, 90 times as dense as that of the Earth, and Mars has a very thin atmosphere, only 0.007 of the Earth's atmosphere. So in the case of both Venus and Mars, they have very high percentages of CO2 in their atmosphere, carbon dioxide. And so they have a relatively much stronger greenhouse effect compared to the Earth, which only has 0.03% of our atmosphere is CO2. Yet, in spite of that, our greenhouse effect raises the Earth's temperature by about 33 degrees centigrade by trapping in that heat energy. In the case of Venus, it has a much denser atmosphere that is a much higher percentage of CO2, and so they have a greenhouse effect of plus 523 centigrade degrees. Mars, having a very thin atmosphere, which is mostly CO2, because it's much thinner, only has a plus 10 centigrade greenhouse effect. So it's a good thing we've got a greenhouse effect on the Earth, because without it, the Earth's temperature, the average temperature, would be minus 18 degrees centigrade. Water would be frozen most of the time, and life as we know it would not exist. But because of that plus 33 degrees greenhouse effect, the Earth's average temperature is actually 15 degrees centigrade. The problem is that we're raising this low amount of CO2 in our atmosphere, holding in more heat, and raising the temperature. Another way that we look at this from a scientific perspective over the time is to take ice cores in places like Antarctica. From those ice cores, we get a record of the CO2 concentration in the atmosphere, because they're little bubbles that were frozen since the time that that ice formed, that give us a sample of what the atmospheric composition was at that time. And based on the ratio of heavy water to normal weight water, we also get a measure of the temperature of the ocean's surface at the time that that ice formed. So, not surprisingly, we see that as CO2 concentration increases, temperature follows, CO2 concentrations come down, temperature follows, and this is a record over the last 160,000 years. So from present at year zero, back 160,000 years, there has been a pretty good correspondence between CO2 concentration in the atmosphere and the Earth's average temperature. Here's what we've been doing just since the 1960s. Prior to the Industrial Revolution, the background concentration of CO2 in our atmosphere was about 280 parts per million. And that's what we saw here. About the highest across that 160,000 years was around 280 parts per million carbon dioxide. But now, since 1960, we have been, well, since 1880, we've been raising it from 280 parts per million to today, we have 424 parts per million CO2 in our atmosphere. And this is how it's changed since 1960. So that's a huge change. Anybody know what this little red squiggle might be? That's the actual record, and then the black line is the annual average. Yes, David.
Yeah, it's the winter and summer change of photosynthesis of plants in the northern hemisphere.
Very good. Yes. So yeah, so CO2 is the basis of living systems exchange with the atmosphere, in addition to other things. So when photosynthesis happens, CO2 is a raw material, and plants combine CO2, water, and sunlight energy to form things like carbohydrates, chemical energy that can be used to power their lives and then can be eaten by organisms like us to power our lives. When we respire, when we use that chemical energy, we take in oxygen to basically burn that chemical energy physiologically and release CO2 as a waste product. So photosynthesis takes in CO2 and respiration gives off CO2. And so in the summer, there's relatively more photosynthesis. And in the winter, there's relatively more respiration. So which of would the peaks here be winter and the troughs be summer? Yeah. So these are the annual changes. And the reason that we see this annual change is because this is taken out on Mauna Loa in the middle of the Pacific. And there's relatively little exchange between the northern hemisphere's atmosphere and the southern hemisphere's atmosphere. So we can see these patterns of ups and downs because there's not much mixing between the north and the south. Is everybody following me?
Mm-hmm.
So to me as a biologist, the distance from the peak to the trough here, that's a huge change in atmospheric CO2 concentration because it represents the net difference in the seasons of the relative amount of photosynthesis in the entire northern hemisphere relative to respiration in the entire northern hemisphere. So that's a huge change. And then compare that to the amplitude of this change. So we've just since 1960, we've changed concentration of CO2 by this much, whereas all of photosynthesis and respiration in North America in the northern hemisphere causes this much change. So anyway, we have changed the concentration by a very large amount relative to what's the normal fluctuation in the Earth's atmosphere. I want to go through one more set of records, past records of Earth's average temperature, so that we can talk about forcing factors. So this is a record here from the present to 300 million years ago on this axis here. And across that 300 million years, we can see that the Earth's temperature changed about 10 degrees centigrade. And the reason for that particular change is because of the tectonic shift. So where were the continents located and how did that affect the circulation of the oceans? Because the oceans ultimately store that heat energy that's coming in from the sun. So as those global circulation patterns changed because of tectonic shifts, we saw about a 10 degrees centigrade rise and fall in the Earth's average temperature. So in that case, we call the forcing factor there. It's a natural forcing factor. It's the tectonic shift that caused that kind of change across a 300 million year timescale. If we expand out the last 3 million years of that 300 million years and take a look at the pattern from there, we see this pattern in the Earth's average temperature across only a 6 degree centigrade range of variation. And we're seeing this fairly regular shift. What's that about? Well, we refer to that regular change in the Earth's average temperature as the Milankovitch cycles. It results from all the changes. There are various cycles in our shift around our orbit around the sun. So there's changes in the eccentricity of that orbit around the sun. There's changes in the tilt of the Earth's axis relative to that plane of rotation around the sun. And, there's sunspot cycles that occur on an 11-year cycle. All of those different cycles combined result in this shift in the Earth's average temperature. And all of that combined change in the Earth's orbit around the sun is referred to as the Milankovitch cycles. So if we expand out the last 50,000 years of that 3 million year record, we see this. We see that warming, that shift from cold toward warm at about 12,000 to 14,000 years ago. And what was that? That's when we came out of the last ice age. So really, these Milankovitch cycles are what caused the ice ages. And across that last 50,000 years, we see that pattern. So we see smaller variation than this change out of the last ice age, and then again, smaller variation from there. If we look at the last 1,000 years of that 50,000 years, we see this. And what we see now is just across a 1 degree centigrade scale of variation. So over this shorter amount of time, we're not seeing nearly as big of a range of variation, but there are all kinds of smaller things that affect the Earth's average temperature. Some major volcanic eruptions have caused the Earth to cool across this time period. And the way eruptions work is in the first 2 to 3 years, because they're putting soot and aerosols and so forth up into the atmosphere, they actually have a cooling effect. But overall, in the longer term, they have a heating effect because they're putting more greenhouse gases into the atmosphere. But in any case, across the last 1,000 years, we've only seen less than a degree centigrade change in the Earth's average temperature. So we call these different things the tectonic shift, the orbital shifts, and then these smaller historical things like volcanic eruptions. Those are all natural forcing factors that climate scientists talk about, compared to anthropogenic forcing factors. So those natural forcing factors change the Earth's average temperature. And now by adding greenhouse gases to the atmosphere through human activity, we are now seeing anthropogenic or human-caused forcing of the Earth's average temperature. And climate scientists take all of those various forcing factors, put them into a model. This is from the IPCC's report from 2007. The IPCC is the Governmental Panel on Climate Change, which is a body of a large number of scientists from around the globe who look at the research done on climate change and make reports to political leaders and to everyone about what's going on with climate change. In this upper graph, what you see, in both graphs, what you see, the black line is the actual temperature record from about 1900 up through about 2005. And then what the red output in the upper graph is from the model that the climate scientists put together to try to see if they could understand how all the different variables and the strength of the different variables affect the Earth's average temperature. And in this model, they ran it over the last 100 years to see to what extent it could predict what we already know to be the case. And that's one way you can test your model. And they looked at these results and they said, yeah, this model is pretty good. It fairly accurately predicts what we already know to have taken place. And that's with all the anthropogenic forcing factors and the natural forcing factors included in the model. Then they ran the model again with only the natural forcing factors. And prior to about 1960, the model still was fairly close to the reality that we measured on the Earth across that time period. But starting in about 1960, the model diverged from the actual record because of the absence of the human forcing factors, okay? So without the human forcing factors, what this model is saying is that the Earth's average temperature would have declined slightly or at least held steady since the 1960s, when in fact it's been rising. And what's the difference? The reason for that difference is the anthropogenic forcing factors. So the human-caused change in greenhouse gases, reflectivity of the Earth's surface, is the reason for this rising temperature. This really is the smoking gun. This is the smoking gun that says that since the 1960s, at least, the rise in the Earth's temperature that we've seen is due entirely to human forcing factors. Okay? So they already did this analysis first in 1991. So we've known since 1991 that current climate change is caused by human activity, period. There has not been any doubt in the scientific community since 1991 that this current climate change is caused by us. And that question arises all the time. You hear people say, well, what part of climate change is caused by human activity? Well, in terms of what we've been seeing since the 1960s, in terms of average temperature rise of the Earth, it's 100% due to human activity. There's just not any question about it anymore, and there hasn't been for a long time. And here's what that record looks like. Each turn of the circle here is a year. You can see the months around the outside going from 1850 up through 2016. And you can see two things in this projection, well, in this showing of the record. One, the temperature keeps rising. And two, the speed of that rise keeps increasing. So there's no question that humans have caused this, and there's no question that the Earth's average temperature is rising. So what are we doing to the climate? In a nutshell, we're adding thermal energy to the atmosphere and the oceans, and that thermal energy is really what drives weather. So We put more energy into the atmosphere and more heat energy on the surface of the land and the surface of the oceans. And what do we expect? Well, we're giving more power to the weather systems, so we expect more extremes of all sorts. I put this picture of the Earth here. This is probably the most commonly used picture of the Earth from space. And I put it in this orientation, not for any particular political reason, with, the Antarctica at the top end of the globe. I put it in this orientation so y'all can see Old Man Wind. So I don't know if y'all see him, but here's an eyeball, here's another eye, here's his nose, here's his howling beard, wisp of hair. So what are we doing? We are giving Old Man Wind that much more energy to howl up a storm. So if you don't remember any of the data, just remember Old Man Wind, right? And you'll never be able to see this picture of the Earth again without seeing Old Man Wind in it. Okay, so we expect that there will be more and more extremes, and in fact, there have been more and more extremes. This is a graph from Deutsche Welle, which is an international news agency that was showing how floods have increased, how storms have increased, and how droughts have increased. The only reason that the droughts aren't as high as storms and floods is just how do you count a drought? Well, usually it affects a whole huge region. So let's say North Africa is in a drought conditions, that still just counts as one. Whereas storms and floods occur on a slightly smaller scale. And so the number of those shows a more marked increase on a graph like this. But all of these things are increasing in frequency. And the insurance agencies know about this. They've been keeping track of these kinds of things. And in this graph, the dark blue is the amount of economic loss from climate catastrophes. And the dark blue is the insured loss, and the green is the overall losses, the uninsured losses as well. So we can see that those have been increasing steadily, as we might expect if we're seeing more and more extremes in climate. So all of these things that we're talking about, rising temperature, rising intensity of storms, floods, and droughts, are leading to more and more people being displaced from their homes. This is from the Internal Displacement Monitoring Center in Norway, and they've been keeping track of this for many, many years. Last year, 32.6 million people were displaced by climate disasters. And again, people don't make these decisions lightly. They decide to flee their homes only when they can no longer support their families. And the breakdown for that, so if we look at overall displacement of folks, conflict, of course, is another big category of reasons that people flee their homes. But if you look at the total displacements in 2020, where 40.5 million people fled their homes, 31 million of those were due to natural disasters. Of those, we've got the weather-related disasters versus the geophysical, earthquakes and volcanic eruptions and so forth. So 30 million people in 2020 fled their homes because of climate-related disasters. In 2019, it was 25 million, 2020, 30 million, 2021, 24 million. Last year, it was 33 million folks. And the World Bank did a very detailed and careful study of this, and they project that by 2050, we will be seeing 216 million climate refugees per year. So these numbers have been increasing, and they are expected to increase more and more as temperature rises more and more rapidly. Yeah, David.
Was that projection of 216 million by 2050, was that based on business as usual or based on achieving a 1.5, limiting global warming to 1.5? Did they go into that kind of detail?
They did go into, this is a really very, very detailed socioeconomic study. And the 216 million is with business as usual. If we follow, and we'll talk about this more in more detail later, if we follow the Sustainable Development Goals and keep people from falling through the cracks as these changes take place, then the number of refugees would be much lower.
Thank you.
You know, and the way these numbers break down, this is just an example from 2017 where we had 3 major hurricanes come through the United States. And you can look at the number of people displaced in each of the different countries, in each area in the United States from each one. But basically, these studies are very detailed, and we know exactly how these different storms or droughts or floods have affected people. And here's another breakdown, again, from the IDMC in 2018. And so we can look at those things in excruciating detail. But basically, it comes down to storms, floods, monsoon floods, droughts, and so forth. All of these various climate-related triggers for displacement. We can break those down into different kinds. So rapid onset climate impacts are things like high temperatures that come on suddenly, hurricanes and storms that come on suddenly, floods which come on suddenly, and wildfires which come on even more suddenly, as opposed to slower onset climate impacts like water stress and drought, crop failure, and sea level rise. Sea level rise being one of the one here that we can predict with much greater certainty. The others are a little bit harder to predict, especially all these water-related things, because as temperature rises, of course, the ability of the atmosphere to hold water increases. So it can transport more water the higher its temperature is. Hot air holds more water than cold air. The thing that's also harder to sort of understand is that if you take a look here, usually weather phenomena of various sorts follow what's referred to as a bell curve, a normal distribution. And so if this is the average temperature here, then we expect to see extreme hot weather like this and extreme cold weather like this. If the average shifts from here to here, what does that mean in terms of more extreme hot temperatures? Well, what used to be our extreme hot temperatures become much more frequent, and we get these new extremes, which are above and beyond anything we saw before. So as the average temperature shifts a little bit, the extremes become much more frequent. And we're seeing that around the world. So this is deaths in England and Wales corresponding with heat waves. So this is the overall death rate, and you can see that there's a bump up in that death rate during a period of heat wave. These are data from Las Vegas, Nevada. The red line is the heat index, and the dashed blue line is the number of deaths. So these things correspond to one another. This is heat deaths in Arizona across the years. And you can see that in general, they are rising. This is a different from Maricopa County specifically. And again, heat deaths are rising here in Arizona. We made national news back in 2019 with the number of heat deaths in Nevada and Arizona. And it's not just heat deaths, but heat stress. So number of emergency room visits due to heat stress has been increasing year after year. in central Arizona. The impact of those storms is various. I don't know how many of y'all remember Hurricane Katrina in 2005. It killed almost 2,000 folks, displaced over 400,000 folks. Some of those folks fled to Flagstaff and are still here. And the overall cost of that storm was 161 billion. We can see that storms have been increasing in frequency. This particular graph shows a dramatic increase in numbers of storms since the 1970s. Hurricane Sandy, I don't know if you all remember that, 2012, displaced 750,000 folks and cost 71 billion. Hurricane Harvey, 2017, displaced over 30,000 and cost over 125 billion. Hurricane Maria, also in 2017, really hit Puerto Rico very hard and killed over 3,000 folks, displaced over 130,000. The numbers here are a little bit more difficult because there's less record keeping in Puerto Rico, and it cost over 90 billion. Hurricane Ian, I don't know if y'all even registered this. It was one of the 3 that hit the United States back in 2017. Sorry, not 2017, 2022. So last year, killed 161, displaced over 40,000, and cost 113 billion. We're now getting these mega storms at such frequency, hard to even pay attention to. Hurricane Laura in 2020 hit Louisiana. In this case, it took out some of the power plants there. So people were seeing extreme heat stress because there was no electricity to power their air conditioners. So this poor lady had been in her overheated home for many days. She went out to get supplies and fainted in the parking lot from heat stress. Some parts of the world are hit harder than us. So I don't know if you all remember Typhoon Haiyan back in 2013, but it killed over 6,300 folks and displaced over 4 million. This one probably didn't register for most folks in the United States. This was back in 2017, where Peru was seeing massive rain and flooding, where over 90 folks were killed and 100,000 displaced. So we're seeing more and more of that kind of hurricane type of storm. We're also seeing increase in the frequency of tornadoes in the United States. So this is US data, 1950 to 2018. And I don't know if you all remember Hurricane Joplin back in 2011. This hurricane, I'm just calling it a hurricane. It was a tornado, but of hurricane type of size. So this was something that did not form out over the ocean. It formed on land like tornadoes do. And it had a swath that was over a mile wide. So tornadoes are getting larger. They were taking out not just wooden structures, but even cinder block schools were taken out by Joplin. Flooding is on the increase, even in the United States. Even though we have lots of flooding damage here in Arizona, it's not of a high enough scale to make it onto this national map of flooding. And of course, flooding worldwide is huge. This is data from UNICEF looking at the displacement of children by flooding in different parts of the world. And back then in 2015, there were 530 million children who were displaced by flooding. Some of the pictures are dramatic. I guess we don't make it onto the map in Arizona, largely because our floods tend to be smaller, more localized. So even though they have devastating effects on some people and some people's homes, overall, it does not register on the national scale. I want to spend a minute and talk about drought, because drought is a little bit more complicated. how do we use that term drought? Well, it's whenever the conditions are drier than we want them to be or expect them to be, we say drought. Now, overall, in the continental United States, we've seen an increase in the amount of precipitation. Here's the record from 1900 up through 2009. And you can see that we've had about a 5% increase in precipitation in the United States. But it's not even. So some areas have seen increases and other areas have seen decreases in precipitation. So so this is a period 2003 to 2007. And across that time, southern Minnesota and northern Iowa had been seeing increases in precipitation. Yet, in 2006 and 2007, here's what the cornfields in southern Minnesota looked like. And farmers were crying drought, even though they had seen a slight increase in the amount of rainfall. How's that possible? So again here, this is a map. That area during that time period had seen about a 5% increase in rainfall. But the other thing that's going on there is that the temperatures are rising. So even though there's a slight increase in rainfall, the temperature has been rising, and therefore there's that much more evaporative loss. So a slight increase in rainfall is not enough to give the plants enough water to grow in the soil that they're growing in, because as temperature rises linearly, evaporative loss rises exponentially. Okay. So what's available for plant growth depends not just on precipitation, but also on evaporative loss. That is due to temperature. So this is the equation for the Palmer Drought Severity Index, and the two main variables in here are precipitation and temperature. And the Palmer Drought Severity Index is a way to measure expectations for amount of soil moisture available for plant growth and hence agricultural productivity. This is a projection by the United Nations Environment Program back in 2009. And as climate changes, we expect many parts of the world to see drops in agricultural productivity due to things like more variable precipitation and increasing evaporative loss. And a large chunk of the United States is expected to see that kind of drop in agricultural productivity. Our planting zones are already moving northward, and so some farmers are having to shift to new kinds of crops that grow under the new conditions. And overall, that warming is not even across the entire globe. So even though we've now seen about a 1.3 degrees centigrade rise in the Earth's average temperature since the Industrial Revolution, some areas are getting hot faster than others. And so one thing that we're seeing globally is what's called polar amplification. So some areas at the highest latitudes have already seen a 3 degree centigrade rise in average temperature. And that's largely because in those areas that were once covered by snow and ice, the snow and ice is melting. And so more of the heat energy from the sun is absorbed by the Earth's surface, and less of it is reflected from snow surfaces, and more of it is now absorbed by darker soil and forest and other types of surfaces. One of the areas where we've seen this kind of thing is, well, in terms of agricultural productivity, is Lacrete, Alberta. Alberta, Canada, you all familiar with the area. This is Edmonton, which is kind of in the center of Alberta, and Lacrete is a little community north of Edmonton. This was an article from the Wall Street Journal back in 2018, where they saw that Lacrete had already seen a 3.6 degree Fahrenheit rise in temperature. That's about a 1.8 degree centigrade rise in temperature. And as a result of that, they were seeing that So average temperature is rising in that part of Alberta. And corn production was rising not only in Lacrete, but overall in Canada because growing season was getting longer. So the date of planting was getting earlier and earlier across time. The end of season, time of harvest, was getting later and later because of rising temperatures. And corn production in Canada was seeing a steady increase. If you look at the value of corn producing land in Canada or Alberta or the US or Iowa specifically, each of these bars here represents the value of that land relative to the previous year. And so generally in Canada, corn producing land was more and more valuable year after year. In Alberta, more and more valuable year after year. In the US overall, there were some years in which the value of that land dropped because there was less productivity. In Iowa specifically, there are some years in which the value of that corn producing land dropped, again, because corn production in Iowa has been getting more volatile. We think of Iowa as the king of corn, but it may soon be Lacrete and northern Alberta that is the king of corn. The shift is already happening. So I want to talk about global climate refugees a little bit by going through the example of what happened in Syria. We think of the Syrian revolution back in 2009, 2010, and into 2011 as being just a human conflict story. But in fact, that entire conflict was started by climate change. So let me go through the steps with you. We know that there are lots of, in Syria, there are lots of sectarian divisions. There was serious drought in 2007 to 2010, where 1.5 million Sunni farmers fled the land and fled to the cities. The Alawite, which is a sect of Shiite, did not support the refugees in the cities, and that ultimately led to the war. We'll talk about the steps here. So the timeline of events: drought from 1988 to 93, more severe drought 98 to 2000, and then longer drought as predicted should occur by all the climate models during this time period, drove people off the land. And so in the cities, the Syrian cities, you had already lots of Iraqi war refugees. And then during this drought, you had all these folks, all these Sunni farmers coming into the cities because they could no longer support their families on the land. This kind of drought is projected by all the climate models for that region, and it's expected to be most severe in some parts of Syria. And here's what we were seeing in Syria from 1900 up to 2000, and it's about 2012 maybe. We were seeing overall decreases in rainfall with some extensive drops right around the 2009, 2008 period. We were seeing rising temperatures as we're seeing around the world. And the Palmer Drought Severity Index, which is that combination of temperature and rainfall impacts, was showing that overall soil moisture for plant productivity was dropping dramatically during the time that the Syrian revolution was coming on. And all this is happening at the same time that across that whole period, Syrian human populations were increasing. So here's what the fields look like. Remember what I showed you drought looked like in southern Minnesota? So drought in Syria is a whole nother level, right? Folks were very, very stressed by the kinds of droughts they were seeing in 2008 through 2010. And here's overall Syrian wheat production from 1960 up through 2015. And you can see that there were some droughts, and that the drought that happened in 2007 to 2008 did dramatically drop wheat productivity in Syria. Here's another graph that includes not just Syria, which is the purple line, but also Iraq, Egypt, Iran, and Turkey. They all saw that drop in wheat productivity in 2008. And you've got to look at that also, not just in terms of the total drop in wheat productivity, but also how much wheat productivity was there per person. Because remember, human populations have been increasing across this whole time period. And so the amount of wheat available per person in Syria was at an all-time low. It was at a low for the entire region. And so they couldn't just import wheat from neighboring countries. So this was really stressing to the folks who made their living from the land. And again, all these Sunni farmers who are out here stressed by the drought are fleeing to cities that are of different Muslim beliefs. And the government itself is made up of folks who belong to the Alawite sect of Shiite beliefs. So these folks are fleeing to the cities, and the cities are already overwhelmed with refugees from the Iraqi war. And over time, as more and more people accumulate in the cities, they become more and more stressed because the government can't take care of them. And whether the government was doing all it could or not, the Sunni farmers didn't trust the Alawite government, and so they didn't think that they were being treated fairly. And the street protests got more and more extreme. And then in May of 2011, those street protests began to turn violent. When that happened and the violence started rising, half the Syrian army defected, the Sunni half, to defend the farmers and refugees in the cities. And that was the start of the Syrian revolution, the Syrian war, if you would. Then by 2014, the cities were full, war was exacerbating everything, and the food lines were getting extreme, and people were beginning to flee the country. By the end of the war, so this is a Syrian refugee camp on the border with Turkey. By the time the conflict was over, more than half the population of Syria had fled. And they joined these long caravans going towards Europe in hopes of being able to survive there. If you look at disaster-induced displacements worldwide in 2012, this whole disaster fleeing of Syria was not even included because they considered it to be human conflict that was driving people out and not a natural disaster of any sort. Okay. So with that kind of as a background, let's now talk about Arizona's future. And if you're curious, I'm shooting for being done by about 3:30, and then we'll open everything up for discussion. But again, if you have questions during any of this, please stop me. So In Arizona, we have what I would refer to as, since I'm a biologist, I distinguish between climate migrants. Those are folks who move temporarily and then go back to their original location, versus climate refugees, where the situation at home is so bad, they never expect to return and really couldn't support their families if they did. So we see a lot of climate migrants in Flagstaff. These are folks who come up for the summer. They come up to have a weekend rental to escape the heat, or if they can afford it, second home, so they can come and spend the summer to escape the heat in central Arizona. Refugees, we have some here that are already here in Flagstaff, as I mentioned, from Hurricane Katrina. And we can expect more and more rising sea level refugees. We'll look a little bit at the economic and social costs of rising temperatures, and then look in more detail at our neighbors in Central America and what's going on with them as a result of climate change. We all know that our temperatures here in Arizona have been rising steadily. This is a record from Phoenix from the 1930s up until, where does it go? 2016. And you can see that the average temperature has been rising dramatically. This scale makes it look even more dramatic than it normally does. If you look at it on a different scale, from 1900 to 2016, 2017, I should say, most of the temperature records have been set in the last few decades. But there's no question, temperatures have been rising steadily. And again, as we shift the average, because all of these weather phenomenon are distributed about that average in what's called a normal distribution, what were the heat extremes here become more frequent, and whole new extremes emerge beyond what we've seen in the past. Okay, so we often talk about average temperature shifting without really knowing how that affects the distribution of temperatures or other weather phenomenon. But this kind of illustrates how a shift in the average greatly increases the frequency of the extremes. Okay, and so we've been seeing those extremes in Phoenix, Arizona. 2017, we saw 119 degrees, and this last summer, we saw that many, many times. Yuma saw a record of 120 degrees back in 2017. But this is a record from Phoenix this past July, and we can see several days that were 119, 118. And so we expect the frequency of those extremes to keep increasing. And of course, those are average temperatures for the city. There are more extremes in different places. So here's a trash bin that melted, a plastic mailbox post that melted. So we're seeing all kinds of very extreme temperatures in different locations. And of course, you know, for folks with pets, you've got to understand that even though the air temperature is 119, the temperature of the black asphalt is quite a bit higher than that. And you really don't want to take your pets out on those surfaces. You'll burn their feet. So we're seeing number of days above 110 degrees. This is a projection from a few years ago, but we're expecting to see 47 days above 110 by 2060, 76 days above 110 by the year 2100. I think since those projections were made in 2019, they're a good bit out of date now. And so here, these are days above 115 degrees. In 2050, we can expect 20 days above 115. By 2075, it'll be almost 30. By the year 2100, it'll be 60 days per year above 115 degrees. We're seeing more and more deadly heat waves. And Phoenix knows that they're seeing this, and they're seeing more emergency room visits and all these things. So this is from the National Climate Assessment of 2018. At that point, the city of Phoenix had already installed all of these hydration stations and cooling refuges for folks to escape extreme heat conditions wherever they might be in their homes. And they're building more and more of these because they want to reduce the number of heat-related deaths and emergency room visits from heat stress. Flagstaff, I mentioned the pressures of folks coming up during the summers for a weekend to escape the heat or buying a second home even. Those kinds of pressures have affected Flagstaff's housing market in a big way. Flagstaff is ranked in the top 10 cities in the United States for second home sales. Part of that pressure is because of the extreme heat in central Arizona. People want a second home and a cooler climate, that being Flagstaff, if they can afford it. If they can't, they come up for the weekend. And that also puts a pressure on our housing market because things that would be rentals become Airbnbs instead, meaning there are that many fewer rentals available. These are locations where you remember we talked about Hurricane Maria in 2017 affecting folks in Puerto Rico. These are the locations from which FEMA relief applications were filed by folks who had fled Hurricane Maria, and some of them ended up in Phoenix. So we're seeing, again, this is just an example of climate refugees ending up in Arizona from climate disasters elsewhere. This was a detailed study by Hauer that got published in Nature Climate Change in 2017. He was looking at where people would be fleeing because of sea level rise and where they would be going to based on various socioeconomic models. This is his graph, and you can see that it was done on a county by county basis. And some of the areas in the southern tip of Florida are expecting to see lots of people fleeing due to sea level rise. And we can expect some of those folks to show up here in Coconino County. This is the same study, but basically a nicer graph done by National Geographic when they told the story in their magazine. And Miami-Dade, Florida, can expect to see 2 million refugees leaving by the year 2100. And that's a projection way into the future. Already in 2017, and I didn't keep this slide in here, but there was a story in the Wall Street Journal again that was about property values in Miami. Those right on the coast at that point had already seen a 7% decline in value because of rising sea level. And people at that time were selling their beachfront properties and moving inland, gentrifying some of those inland neighborhoods in ways that would make them less and less affordable for other folks. So that's just one other way in which climate change is affecting people. This is that World Bank study that I referred to earlier. It's called Groundswell. And when they first came out with the part one of this study back in 2018, they were projecting that we would see 143 million climate migrants by the year 2050. In 2021, they came out with an update of that study called Part 2, which then was projecting 216 million climate migrants per year by the year 2050. They broke this down by different parts of the world and, the different kinds of stresses that you see in each region. So 86 million expected to flee sub-Saharan Africa, 40 million South Asia, and 17 million expected to flee from Latin America. These are the different emissions scenarios that they included in their study. And this is the business as usual one, and really that's what we've been following so far. We've made various attempts to reduce our emissions, but really we have not attained significant reduction in our emissions. We keep on skyrocketing to higher and higher emissions levels. We're now emitting at a rate of about 59 gigatons of CO2 per year. And here's the projected outcomes for different parts of Central America. And this top is the water gap if we go at the highest emissions rates. If we go to the lowest possible emission rates, RCP 2.6, then the amount of reduction in water availability is much less extreme. So we should be shooting for reducing our emissions as much as possible. So this is the water availability graph. And here's the agricultural productivity graph. So as water availability drops, of course, agricultural productivity is going to drop with it. Business as usual, if we rein in our emissions by a lot, we could have much less impact, but there'll still be some impact because it wouldn't reverse the amount of CO2 that we've already put into the atmosphere. If we follow the United Nations Sustainable Development Goals, that is, protect people from poverty, hunger, mental health issues, provide education and job training. So if we're going to go through this massive shift away from burning fossil fuels and away from producing CO2, it's going to require a huge amount of retraining of people. So the folks who work at the filling stations will need to get new job skills to work at the electric car charging stations. Those folks who work on combustion engines will need to be retrained to work on vehicles that are powered by, ideally, clean electricity, and so forth. So if we follow all of these recommendations by the United Nations, then we can expect much fewer, much lower numbers of refugees. And so that in that groundswell report, they talk about if we follow this or that socioeconomic model, more inclusive development, the pessimistic reference, which is the RCP 8.5 emissions, or more climate friendly. So they projected different levels of refugeeism for all of those different scenarios. And I'm just showing you one example here. In Central America, and this really did not hit the news very well. I mean, there were occasional stories like this from 2019 about people being stressed by drought in Central America. And really, this is the region that was affected, that has been affected by major increases in extent and frequency of drought. And it affects farmers at different elevations in these countries differently. So in El Salvador, for instance, in the mid-range elevations where people grow coffee, there has been a decrease in amount of rainfall, but mainly there's been a shift in the seasonality of that rainfall, which has brought in whole new crop diseases that they haven't had to deal with in the past that have reduced their harvest. So climate change is affecting drought, but that cascades into all kinds of other problems for farmers in that region. So that dry corridor is the primary source of refugees showing up at Arizona's southern border. This doesn't really get to us in the news, but that's the way it is. And here, if you look at these poor farmers, they really do not have good irrigation systems. So when the drought hits, they're kind of up the creek. I think you can see that they tried to put in some kind of a drip system here, but probably their water supply for that is not good enough. And their crops, in this case, melons, are dying. And they're not just hit by the drought, of course, they're also hit by major storms. So Hurricane Mitch in 1998 hit Tegucigalpa, Honduras. And Dr. Reamer can probably tell us more of the details of some of this because she works in Central America. But I'm trying to give you just a brief overview here. This is the number of folks who are showing up at Arizona's southern border from the countries of Guatemala, El Salvador, Honduras, and the total number of folks coming from these northern triangle countries. Okay, and you can see that that number keeps increasing year after year up through 2018. Here's some more recent data up through 2023. And you can see that most of these folks, 2020, you saw this kind of annual variation in folks showing up at our southern border. In 2021 is the blue line. In 2022, that's the flesh-colored line. And 2023 is the dark blue grayish line. So we can expect those kinds of numbers to keep increasing as projected by the World Bank's groundswell study. There's just some detail about how the different, what they break down their land into what they call departments, and rainfall and overall percentile drop in crop productivity. The Biden administration early on recognized that they needed to address the root cause. So a lot of the foreign aid that the US was providing for Central American countries was in agricultural assistance, food assistance, and US foreign assistance in terms of economic and military. And you can see that the assistance for agriculture and food was much lower. And so the difference here is the military. So we were putting way too much of our foreign aid into bolstering the military in those countries, where we should have been helping the poor farmers survive this more extreme drought and other seasonal changes that were reducing their productivity. So the problem is big, the problem is global, the problem is local and regional as well. It affects us in all sorts of ways that we don't always make the direct connection to, but we need to. And we need to understand that to solve all of these massive global and regional and local problems, the solution underlying all of those would be to reduce our carbon footprint. So what can we do? First and foremost, we need to reduce our carbon footprint to stop exacerbating these kinds of problems on a global level. We need to vote for climate-aware candidates. We can no longer afford to have uneducated people leading our country into climate disaster because they do not understand what's going on. We cannot afford that kind of leadership anymore, anywhere in the world, and certainly not here in the United States, not here in Arizona, not here in Coconino County, not here in Flagstaff. We need to get more responsible, more in touch leadership. We need to develop and implement carbon-free technologies, and largely we've developed them just fine. We need to implement them on much broader scales. We need to pay attention to the United Nations Sustainable Development Goals if we want to go through this massive societal transition away from fossil fuels to clean energy. And we need to pay attention to those folks who will be hit hardest by all of these changes. Usually it's the folks with the least economic buffer who are hit the hardest. The folks in countries with less infrastructure are hit harder. And so we need to pay attention to those things if we're going to come through this transition in a healthy and whole and intact kind of way. All right, so I just want to end by reminding you all that this is part of a Climate Talks series, Climate Talks for Everyone. You can find out more information about the series at the NASCA website. And we hope that you all will be motivated by all of this to do as much as you possibly can to fight climate change. And please join us by clicking on nazca.org/volunteer. And you can join. We've got groups going in Flagstaff, Sedona, Cottonwood Verde Valley, and Prescott Quad Cities. We need your help in all of those areas. All right, and with that, I'll stop sharing my screen so we can all see each other better and open this up to any questions and discussion. Any comments that folks would like to contribute, please jump in.
Sure.
Is there any climate-induced migration going south of the equator? Are people who are impacted going down into Chile and Peru and Argentina?
That's a very good question. The answer is yes, but the answer is also that I'd know less about what's going on down in the Southern Hemisphere. I apologize, but yeah, so we've been talking about climate migrants, human climate migrants, but we're also seeing the same thing with every species on Earth. So the grasses are fleeing northward here in the Northern Hemisphere and southward in the Southern Hemisphere. The birds are fleeing northward in the Northern Hemisphere and southward in the Southern Hemisphere. So yeah, the same kinds of patterns are going on down there with humans and with other species. I know less about what's going on down there, but I know the same is happening there. Questions, comments? Did I answer everybody's questions too thoroughly?
So, thank you. Elisa, go ahead.
Yeah, I was just going to ask, we're already water stressed. We know that. Is NASCA addressing or do you have efforts, going toward that and that this is just going to exacerbate that problem so much more?
Well, yes, in a general sense. So we have in Flagstaff, for example, we have 14 different climate action teams that are all working on different aspects of our city's carbon footprint. Some of them are pushing the city to electrify their fleets more rapidly than they are. Others are pushing the city to actually implement the city's goal of being net zero emissions by 2030, which the council has recently been making some decisions that go totally against that goal. So those all affect water availability in the sense that our carbon emissions affect temperature and rainfall. Rainfall has been sort of a problem at the opposite end here in Flagstaff because we're seeing more dramatic downpours during monsoons. And this is not just our feeling anymore. There was a 2019 study that documented that, in fact, the monsoons have gotten more intense. And so we have many fire scars around the city. And those fire scars, the areas where the forest has burned or the landscape has burned, have less ability to absorb water. And so when we get these massive monsoon downpours, the landscape can't absorb it, and we get massive flooding here in Flagstaff. We have had cars floating down streets in Flagstaff, Arizona, dry Flagstaff, Arizona. So, that's the kind of water issue that we've had here. But certainly, our water supply is dwindling, and we will soon have much bigger problems because we won't be able to water crops. And our food supply will be affected. So, then that's already happening regionally. And it'll soon be an issue here in Flagstaff as well. We don't have a climate action team that's specifically addressing water in the sense that you're saying, but it is an issue already, and it will become a bigger and bigger issue. So the way climate action teams come about within NASCA, since we are very, very grassroots oriented, if someone has an issue that they would like to address, we seek to empower them to address that issue. So if the water issue is your primary concern, Alyssa, then we would urge you strongly to bring others together, and we'll help you to do that. And figure out, what are the specific initiatives? What are the things that I want to address about water and with which community? It's going to be a little bit different in Prescott than it is in Flagstaff. So, different in each area. But once you know what you want to do, we can empower you. We've got over 18,000 folks have signed NASCA petitions in northern Arizona. Many of those are in Flagstaff. So we have newsletters that go out, and once a climate action team is operating, we tell others about it. And so the climate action team can grow. So we can help folks in that way. I don't know, are you interested maybe in getting something going, Alyssa?
Yeah, I am. Unfortunately, I'm out of the area. I'm in Cottonwood, but I'm living in Ohio for this year till at least the end of March, April to be with my mother. And I don't know if that's going to be extended or not. So I was on the Green Burial team and was doing that remotely. But I can't commit to a whole lot right now because I'm not local.
Understood. But there is a team in Cottonwood. So I don't know if you're connected with them.
No.
Okay. Well, let's work on connecting you with them. And then, maybe by the time you come back at the end of a year, you can be connected, who's active and who's not active down in the Cottonwood area.
Yeah, that sounds good. Thank you.
Yeah, let's do that. Okay. I'll put my email address into the chat. And then if you send me an email, I can start getting you connected.
And water management is certainly on the radar in terms of Sedona's climate action plan, which of course NASCA was involved with moving forward. And I know that the Friends of Verde River has done some really great work around the Verde, and we've been it's supportive of that work. But
Okay.
yeah, if folks are interested in doing something more direct, we're happy to support.
Yeah, I intend to get more involved with them when I come back too. I've done some water monitoring, but it wasn't through them.
Yeah, they've had some real successes locally.
Well, and there's a group in Sedona specifically who have been fighting against development that is above and beyond the carrying capacity for water in the Sedona region. So, that kind of issue has been addressed more or less effectively over the years in different parts of Arizona, often less effectively. But there are ways to say, if you are going to develop here, you need to show that you have a sustainable water supply. And so we've had that kind of legislation on the books in Arizona in various ways. And so groups can work to encourage the implementation, the enforcement of those kinds of regulations, of getting involved in the water issues.
Thank you. Thank you for
Connect
the
you with the folks in
presentation.
Arizona too, since that's fairly close to y'all in Verde Valley.
Okay, thank you for that, and thank you for the presentation.
Thanks, Alyssa. Thanks for being part of this.
Stefan,
Yes,
this
Jill.
is Jill. Do we actually have any climate refugees in Flagstaff? And if so, how have they been received and helped? And are there plans for the future when we are likely to have more refugees?
Good questions. And it's a little bit difficult to get at. So I know that we have folks living here who fled Hurricane Katrina. We probably have folks here who fled Hurricane Maria in Puerto Rico, although I have not met any of them, don't know any of them. The issue with folks fleeing Central America is that they are not always up for talking about it, put it that way. So a few years back, Roy May and I Zoom met with some department officials, agricultural officials down in Honduras who told us about the situation down there. But they also mentioned that none of the farmers, it's first of all, it's the farm workers who have to flee first because the farmers can no longer afford to hire them.
Right.
The farmers have a little bit more resiliency because they own land. So they don't have to flee quite as soon as the farm workers. But those folks who are fleeing, they often don't want to tell you their name. Deutsche Welle did a piece on this where they interviewed a lot of folks coming to the border who would not give their names because they're worried about how they'll be received. They're worried about being recognized as illegal immigrants, all those kinds of issues.
Mhm.
I know we
Mhm.
have a lot of immigrants here in Flagstaff, but I have no idea how many of them they might be climate refugees from the Northern Triangle countries. And
Mhm.
it's information that's hard to come by.
Mhm. Well, and I would guess affordable housing would be a great barrier to any refugees, climate refugees.
Certainly. And we recognize that as an issue here in Flagstaff. And so we need to address it not only because of climate refugees, but because the whole
Yeah.
community is affected by it.
Right. Thank you. And thank you for the presentation.
Thank you, Joe. So I have lots of relatives in Germany, and the Ukraine issue is, it's much clearer. People
Yeah.
who are fleeing the war tell you that they're fleeing the war. You can tell by their accent where they're coming from. So it's a little bit easier. And many families in Germany are taking refugees from the war into their homes. We could be doing the same thing here with refugees, but it's more, as I was saying, more difficult because the folks are not, often they're not willing to speak up
Mhm.
and identify themselves as climate refugees.
Mhm.
But, if we could get a handle on that and send out messages to the community, it seems to me that churches might want to get involved in helping people, climate refugees,
Mhm.
or just refugees in general,
Right.
setting up programs where people allow people into their homes on some temporary basis, or the church helps in some other ways. And many of those programs are in place, not specifically for climate refugees, but for folks who are having a hard time for whatever reason. David.
The ground rules for seeking asylum in our country, am I correct in thinking that asylum seekers cannot use drought and climate crisis as their basis for seeking asylum?
That's correct. Yeah, so it's not recognized
Mm.
that people are refugees if they are fleeing climate or, agricultural losses or whatever, only if they are experiencing political persecution of some sort or, actual outright conflict can they be officially recognized as refugees. And so that level of national law should be changed as well, because we're seeing steady rise in the number of climate refugees, and their refugeeism is very real for very real reasons. We're largely the cause for them becoming refugees. And so for all of those reasons, we should be recognizing them as refugees and treating them accordingly. Okay, well, thank you all very much for coming. I put my email in the chat, so if you have a question that arises later, feel free to email me and I'll do my best to answer whatever questions y'all have. And please do join NASCA. Please do go to the NASCA website and sign up as a volunteer. We have many different things going, many different ways for you to get involved. And if all the things that we're doing aren't the things that you wanted to do, we're very eager to hear from you about what climate action team we should form to help with your particular issue. So thank you all very much for coming out today.
Thank you. Have a great weekend. Thank you, Stefan.
Thank you.
Thank you all.